All right, so hi everyone. I think we're just getting everybody in just from the waiting room. So welcome to our Society's Intro Day. So I'm Ethan, the Vice President of the Society, and this is Cambridge University Robotics. And our motto is just to make robotics accessible for everyone, regardless of their skill level or background or whatnot. So our society is, at a glance, we're comprised of 60 active members, comprising of undergrads and postgrads, anywhere from any skill level, from beginners to veterans. And we're also open to all subjects, but we're mainly comprised of engineering students and ComSci students. We run 5 flagship projects, which can be seen here, but we also are going to talk a little bit more about that later in the presentation, where we have each of our project leaders to introduce and talk about what they're looking for in members and what we're hoping to achieve in each of our projects. And those 5 flagship projects are advised by 5 industry advisors, which you can see here: Autodesk DeepMind, Shadow Robot Wave, and the Cambridge University Bio-Inspired Robotics Lab. We're also here. Our faculty advisor from the Bio-Inspired Robotics Lab is also here to give us a few words about his work and how he sees our society influencing the industry itself. So here's a word from our advisor, Dr. Fumiya Ida, from the Bio-Inspired Robotics Lab. Fumiya? Okay.
Hello. Do you think you can give me the share screen?
Yes. If you could just remote control from there, we'll give that to. Yeah. Here you go.
Okay. Well, let's see. All right. Do you see my screen?
Yeah, it looks good.
Okay. Good. Thank you. All right. Well, thank you very much for the invitation. So my name is Fumiya Ida. I'm one of the academics in the Department of Engineering. And in the context of Cambridge University Robot Society, I'm playing a role of a senior treasurer, in the sense that when we have some financial matters, I need to be responsible for this. And we have a bit of discussions about how to do general directions of the society. So let me give you just a brief introduction of from my view, where we stand in robotics and what the role of Robot Society is. So let me start with a brief introduction from starting with the cover page of the Economist Journal a few years ago. So we are really in an exciting point in history that now the robotic revolution is actually happening around the world. We see lots of news and startup companies and new technologies in medias and any other places we're observing. And there's really 3 main reasons why we're observing this kind of big movement at the moment. The first reason is the technology price is going down every day, that the cost of robot platform like robotic arm and mobile robots getting cheaper and cheaper. And that opens up a new applications of robotics and newcomers easily joining in the community. And the second point is the robotics is becoming easier because we can buy technologies instead of building everything from scratch, from sensors, actuators, and 3D printers, and so on. And the third point is technology is getting faster and faster because of the connected and shared technologies. Engineers nowadays share their development through internet mostly freely, so that you can actually download the mechanical designs or computer programs for free without really knowing too much details of technologies. So all these things come together. I think we are really observing how robotics is transforming our human society. And I'm telling every student in engineering department that if you're doing robotics, you're doing the right thing, because this is the most exciting time of all. And if you're not doing robotics, it's not too late, right? A lot of things are getting easier and lots of big things are happening from now on. So please do think about, seriously about the robotics technologies from now. So where do we see robots? We see lots of robots different places, and here are some examples of today's robotics in our society. So the top left corner, you see the manufacturing robots in car factory, and the robots are more precise, more powerful than humans. So these are driving force for our society moving faster and cheaper in terms of manufacturer technologies. Top right corner is the robotized warehouse from the Kiva system, that is the main provider of the technologies to Amazon warehouse. So robots are delivering items rather than human beings walking around in the warehouse. And then the lower two examples, the Boston Dynamics leg robots and the autonomous drivings, are some new technologies that are coming to our daily life very soon. So we are really in the historical point of transformation. We cannot really live without any robotic technologies anymore. So that's something we're really witnessing at the moment. So where else can robot go? So there are many research on road mapping how robotics could go in the future. And what's really exciting is that it's almost impossible to find places where robots don't go from now on. So starting from manufacturing, cleaning, medical, entertainment, logistics, autonomous car, inspection, surveillance, construction, agriculture, healthcare, elderly care, and the personal service robots. So all of these things are potential places where robot could go if they're not there yet. But this is something we really need to think about in the future. Like, we need to deal with all these industry challenges from now on. And for these reasons, we are all interested in many industry partners and sponsors. So this is some list of the companies that my group of research is dealing with. But many others are there. So these are good opportunities for all the students could potentially work with them or consult with them in the future for the great collaborations. So I told you robotics is interesting and exciting, but at the same time, it's very hard, right? We need to think about lots of different parts and technologies. Robotics is not the single technologies, but the integration of hardware, middleware, and software. So all these things need to be known in one way or the other. But as I said earlier, so robotics is going faster because of the collaboration. So please don't do robotics all alone, but you need to work with other experts and do things together. And this is where I think the Robot Society plays an important role, because this is a place where people meet to each other for the collaboration and for the innovation of the new technologies. So I think this is, from my view, how Department of Engineering in Cambridge University is serving robotics in terms of students' interest and demands. So we have a formal curriculum of robotics-related topics in engineering department. So we have 1A Lego Milestone, which unfortunately doesn't happen this year because of the COVID situation. But second year, IDP is happening this year. And then we have a Europe summer internship for many undergrad students, where you can do various robotics projects over summer. Then the third year, we have extension activities related to robotics. And then the fourth year, we have a robotics modules and the student projects. And furthermore, we have a MPhil and PhD project. So these are kind of formal curriculum that every students in engineering department can participate. But the Robot Society activities are going all in parallel with all this curriculum, because I think a lot of students want to do robotics as early as possible, but many of things don't happen until third year, fourth year. So I think it would be useful to have this kind of a society activities in parallel, so that people can actually start doing a lot of interesting things already from the first year of engineering department. So I think this is a really complementary activities for those who are really excited about robotics in general. So just give you a few examples that what we're doing in our laboratory. So these projects are done by undergrad engineering students. So one of the projects we did last year is the computer vision technologies of recognizing human gestures. So this program is freely available on the internet, and you can actually easily extract behavior as a human, even without really knowing the details of computer vision nowadays. The idea of this is how we can use such advanced technologies for doing different kind of robotics research. So in this case, a human is demonstrating how to cook the pancake, and robot can learn from the demonstration. So this is a new way of programming a robot. Without really programming robots in computer language, you can teach the robot by demonstration. So this kind of technologies used to be a PhD work, right? So the PhD students need to do this kind of thing. But nowadays, because of the shared technology, because of the connected technology, we can actually do it in undergrad level. So undergrad students can already do this very advanced technology 10 years ago. Now I can do it in the, quite easily. Another example of undergrad student project is the robotic dishwasher loading. Similar to the previous one, the students took advantage of a machine learning technique available in the internet to recognize various objects. So in this case, the student went to the canteen of the college and took hundreds of pictures to recognize different objects, and the robot can actually pick up different items in the clutter tray for loading a dishwasher. So again, this is a very advanced research program if it's 10 years ago, but now you can do it, even undergrad students can do it quite easily. So that's something really we're really seeing how our technology is advancing, and undergrad students can do this kind of research and even do the publications out of this. So that's a really, really exciting time now. And yeah, and the one more thing I just want to show is another project, something related to cooking. And this is the project done by one of the Robot Society representative who did program the robots to cook the pancake. It's not pancake, it's the omelets this time. But in this case, he managed to use the machine learning techniques to get the robot learn to cook better omelets, and through interaction with humans, robot can actually learn to cook better omelets after many trial and error. So again, this is that could have been a very challenging project, but this can be done in undergrad students' projects. So hopefully I give you a bit of overview about what students can do nowadays. If you are part of the bigger community with an excellent talent. So I think the Robot Society in general is a great place where you can be most innovative and most creative and most excited most importantly. So doing a lot of things, I think you will hear from Jacob and other members of the Robot Society from now on what we're doing. But you are welcome to propose anything more exciting if you have any ideas. What we're really waiting for is how we can be most creative and excited in this department. Especially this year, we have a problem with the COVID pandemic, and you have very limited accessibility in the physical activities. But hopefully, this kind of extracurricular activity can give you additional opportunity to make your hand dirty, to be creative in the physical world. So feel free to contact us if you have any questions, problems, or desire to do. The examples that the Robot Society is giving you is just one kind of ideas starting point, and we are really, really looking forward to having you, as many of you as possible, to get this community really a good place for the innovation. Okay, I think I'll stop here and probably I'm talking too much, but I hope you will have a lot of fun today with this virtual event, and I hope to see you at some point in the future. Okay, is it okay, Ethan? I think I bring the screen back to you.
All right, thanks so much, Fumia. As you heard from our advisor, Fumia, the robotics is growing really quickly, and some of the best ways of getting into the field as an undergrad or a postgrad is through our robotics society. We have a lot of different projects ranging in difficulty level and interest types. So each of our project leaders now is going to give a quick introduction to their project that they're leading and talk a little bit about what they're doing.
Hi. Should I have my camera on?
It's up to you.
Yeah, I'll just go like that. So, well, hi everyone. A bit of introduction about myself. My name's Jerry, and I'm a year 2 engineering student. I'm the webmaster of CU Robotics and also the project lead of the Varsity Minibot project. So Varsity Minibots is the first phase of the Varsity competition that takes place in Michaelmas term. You will be building Arduino-based robots, and this project is aimed for beginners and intermediate students to help you develop hardware and software skills. So saying that, no previous experience is needed at all. The competition is set in the scene for the robot acting as a life-size version of a Pac-Man, hoping to retrieve points in a maze. Weekly sessions will start at October the 14th, and it will happen every Wednesday, 2 p.m. And we will hopefully, for the next term, we will have a competition against the Oxford Robotics Society. And so to show you the timeline, we got Michaelmas term where we build Varsity Minibots, and we hope to have an internal competition at the end of it. During Land term, hopefully we'll have some strong teams to do more customization to the board, and later on to compete with Oxford at the end of Land. Would you mind going to the next slide, please? And to show you a demo of the minibots that you will be building. So this is the challenge that you will expect this term, and the full arena is on the left side. Thank you very much.
Thanks so much.
I'll just add that this is an introductory project where we don't expect any prior experience from you, and you can also work on different aspects on the robot. So you can, for example, just work on improving the robot mechanically and testing the algorithms your colleagues may, or you can just work on making the software, etc. So robotics in general is a very multidisciplinary area. So, and this project embodies that quite well. So don't be afraid that if you're not specialized in software, it won't be a project for you.
Yeah, thanks, Jerry, and thanks, Jacob. So yeah, just to remind everyone, the first meeting for this is going to be the 14th of October at 2 p.m., likely over Zoom, but more details will come later. And yeah, just don't be afraid to join the project just because you don't have a really broad set of skills across both hardware and software. There is a place for everyone in robotics because it's just so multidisciplinary. Our next project is going to be our rescue robot, which is nicknamed Arbie. So Kai.
Hello, everyone. Just to introduce myself, my name is Kai. I am a 4th-year engineering student, and I am also the chair of the committee, which is effectively a general committee member working on a lot of projects. So I'll give you a little bit of an information and overview about this project. So in contrast to the Varsity Minibots, this is one of the more advanced projects in the society, and we try to cover quite high-level areas, high-level engineering areas across a lot of different disciplines in robotics. So as you can see on the slide, we work on mechanical design, manufacturing and assembly, electrical design, designing a robot operating system. We do machine learning and also autonomous movement. The goal of the project is to create a rapidly manufactured desired response robot. So one you can see on the left-hand side of the screen. And this is for the RoboCup International competition. In this RoboCup competition, the robot is expected to go over different terrains, use the robot arm to open doors and open valves, identify different objects in the meanwhile, and finally autonomously move around the area. Next slide, please. So I will explain a little bit about how we have been working on the project. So this is the Mark II of Arbie, and we have been developing Mark II for the whole year last year. And let's look at the video to see what we've done. Ethan, can you skip to where there was like, yeah, right there is fine, like 32 seconds. Right, so this is one of the tasks the robot is doing. So this was a submission video for the competition, and the robot is successfully going up the stairs. Another thing to note is the robot is being operated by the operator using a Xbox controller. Ethan, can you move to about 2 minutes? Thank you. So the other task is, as mentioned before, a dexterity task where the robot is using the robot arm to open a valve. Here you can see the robot moving its arm down to the valve, while the operator is using the Xbox controller and the customly built user interface to operate the robot arm and successfully open the valve. On the right-hand side of the screen, you can see 4 photos of the internals of the robot. This is the custom PCBs that we built for the robot, the onboard UI. On the top, we see a screenshot of our early developments on the SLAM algorithm, which is simultaneous localization and mapping. So essentially, the robot goes around the room and maps itself. And finally, on the bottom right, you see the user interface of the robot, where you have different camera feeds, the 3D robot positions, as well as the joystick information. So this was Mark II. And for the final slide of this project, I would like to explain what we've been working on recently, which is Mark III. Next slide, please. So Mark III is a complete new build from the mechanical side. It is quite similar from an electronics and a software perspective, but we are still working on the construction of this. On the left-hand side, you see the CAD model, which is almost done. And on the right-hand side, you can see the robot being built. It is slightly difficult with COVID regulations to do a lot of mechanical work, but we're hoping to have a lot of new members looking into autonomous navigation and planning algorithms, because that can be done in software and simulation. And finally, I would like to end on a note of who we're looking for this project. So as mentioned, there's a lot of advanced technical skills involved, from CAD assembly to PCB design to using ROS as a control system for the robot. Unfortunately, we cannot accommodate a lot of people for the project, but we're looking for a few members who can be highly involved and possibly have some past robotics or equivalent experience. But the most important part, we want to have people who are keen and enthusiastic to work with us to make the Mark III robot and perhaps a Mark IV robot in the future better than it is right now. Thank you.
Thank you, Kai, for that introduction. We're really looking forward to seeing Mark III of Arbie in the coming year. So if you're interested in this kind of stuff, there'll be more information about the first meeting for the RescueBot later on in the presentation. Our next project is going to be the a machine learning research project or a policy learning research project, talked about by Jacob.
Yeah. Hi, everyone. I'm the president of the society for this year, and I'm also coordinating the research project together with Ethan. And that's a project that we started with the idea that we want to allow give undergraduates the opportunity to do meaningful research during the year, not just during summer internships. And we've originally started working with Fumiya's bio-inspired robotics lab, where a postdoc named Thomas has been helping us. And we posed like what people's interests are, and because of that are working on a policy learning project, where all of last year we spent looking at this robot with an anthropomorphic passive hand on it and trying to get it to learn how to pick up objects. And we currently have a lot of the infrastructure in place, but we haven't really done much of the learning itself. So here we're looking to mainly working on the machine learning aspects, but like also since you have to go from something, we created the setup you see in the photo, which allows us to measure what force the hand is exerting on the cylinder that we want to pick up. And we're looking for people who have a decent amount of programming experience, since it's 90+% of the project is just software, and ideally some machine learning experience. You don't need to have particular experience with reinforcement learning or robotics, since we will have some introductory sessions for those who don't. But like if you're already really advanced, then we're keen to have you join the main project straight away. Can I have next slide, Stefan? Yeah, so the first video we have is from last year. You can play. From last year, this was a manually input trajectory of how to pick up the object. So, but you can see that it doesn't pick it up perfectly. So an option to go with that is to use residual reinforcement learning and get it to improve this kind of manually inputted trajectory. Then during Easter, we created a simulation you see on the middle image, which we can now use mainly for verifying our ideas without needing access to the physical robot, and without being worried of potentially damaging the physical robot. Then another thing we might be having a look at, if we're not able to access the engineering department, should there be another full lockdown, is, for example, learning movement as a dog grows. So for that, we can use this simulation. This simulation that DeepMind developed. So this is a simulation of a dog that has all the degrees of freedom that a dog normally has, which means it sometimes looks a bit weird, but that's an option of what we could do should we be forced to work only in simulation. And I mentioned that this is from DeepMind, and that's because we've arranged a partnership with DeepMind where they will be we will regularly have meetings with some of their researchers, and they will be helping us out with with supervising the project. And DeepMind will also run some workshops or other events with us later during the year. So yeah, that's everything from me.
Thanks so much, Jacob. So as you can see, this is our very software-focused project. So we're looking to have people who have pretty advanced software skills. There's going to be more information about the first meeting for this research project later on in the presentation. So our next presentation is the InMoov humanoid robot. So.
Right. Hi, I'm Jay. I am a second-year engineer. I am also the Outreach and Sponsorship Director of CUR. And I am the lead of the InMoov humanoid robot project. For this project, we are trying to create a life-sized humanoid robot that's capable of interacting with an audience. As you can see, this is an open source 3D printed robot, and it's going to have 50 degrees of freedom. So this is clearly a very big task. And that's why we've divided ourselves into two sub-themes, the hardware and the software. So this is an intermediate level project. So we expect some level of experience, although I must emphasize that it is a learning project. So if you don't have a lot of any experience, this is actually a good place to learn some of those. So it's not essential that you must have prior experience. Next slide. As you know, the engineering course is quite technical. So this project is going to give you some opportunities to practice your practical skills. And we are looking for people who are highly self-driven, because the progress of how fast this humanoid robot gets built depends 100% on the dedication of its members. So if you are really self-motivated and you want to learn a new skill, because of course this project will give you opportunities to learn skills like how to 3D print, how to assemble the parts, how to do computer vision if you're into that. We are looking for people who are willing to dedicate their time to this project. So if this sounds like a project that you are interested in, come along to our newcomers meeting on 15 October, 4 p.m. We will release the meeting details closer to the date itself. So yeah.
Great. Thanks, Jay. So once again, this is our humanoid 3D printed humanoid robot, and there'll be more information. You'll get to ask questions and get answers to a bunch of questions that you have for all of our projects later on in this session. Our last project, definitely last but not least, our robotics kit development. So Peter, take it away.
Right. Hi, I'm Peter. I'm a second-year engineering at Queen's, and I'm also the treasurer of CUR. I'm involved with the kits project, and that's where we aim to produce do-it-yourself kits that help solve everyday problems that Cambridge students might face in an affordable way. So some ideas we are working on are the IoT light switch, a smart bike light, and an automatic plant watering system. And what really goes into a project like this is design iteration. So CADing parts in Fusion 360 or SolidWorks or KiCad, and then making prototypes that can prototypes that we can improve on with workshop tools like 3D printers or laser cutters. We can get printed circuit boards made in-house. I'm not sure how this will work this year, or get them manufactured outside. So not only will this project help you with technical skills, but we believe it can introduce you to entrepreneurship as you market and sell the products you came up with from scratch. So if you, Ethan, if you do the animation to show different projects that we made. So this is part of the bike light. And if you go to the next slide. Yeah. So what we look for in people is if they have previous experiences in designing and making products, whether this is from DT at school or even personal projects that were interesting. And obviously, you don't have to be an expert. If you have any questions, you can always ask CR members. I'm sure some of you have brilliant ideas you want to make, and CR can help make that idea become a product. So if you go to the next slide. Right, so now I want to introduce you to an event that we have on the 14th. So that's this Wednesday. It's a fireside chat with James Bruton, who's a robotics YouTuber that has made from a fully 3D printed Iron Man suit to an open source robot dog. He has a lot more interesting projects if you look at if you search him up on YouTube. And I'm sure if you've done engineering projects, you've come across him before. So if you had any questions you wanted to ask him, or you just want to talk, please sign up using the QR code on this page. And I think this presentation is recorded, so if you want to look at it, you can look at it later as well. So this is an initiative we started this year, so we plan to host many more talks with interesting people in the robotics industry. So keep an eye out on our Facebook page and our mailing list. Right. Yeah, that's all from me.
Thanks so much, Peter. Yeah, so beyond just the projects that we run, which is quite a bit, we also run a number of events throughout the year. Our first event is going to be this event with James Bruton, but we also have a number of other events planned for later in the year with interesting speakers within the industry, researchers with their work and whatnot. So stay tuned and watch out for our mailing list to see these events and make sure you don't miss them. We wouldn't be able to do this without our partners and advisors. So Jacob, if you take it away.
Yeah, so we've been working with Femias Bio-Inspired Robotics Lab for a while. So there's a long-standing partnership there. But recently we reached out to DeepMind, Autodesk, Shadow Robot, and Wave, where Autodesk and DeepMind will be hosting some workshops in the near future and supporting various projects of ours, where Shadow Robot and Wave, that's there it's more of a partnership where we have a lot to learn from them, and as in them being interesting small companies in the industry. So there we expect to host some fireside chats with the CEOs of either and similar events like that. And maybe in the future there will be a joint project with either of them.
Yep. So thanks so much, Jacob. So again, we wouldn't be able to do this without our partners and advisors. We partner with a lot of interesting companies, and we look forward to working with them in the coming year. So given our resources and our projects, there's also a lot more room for suggestions. So if you have any other projects or ideas that you have for robotics, you're welcome to voice them to any of us, any of the committee. So please do join our team. So here's a list of each of the initial meetings for each of our projects. And if you'd like a reminder for them and you'd like to learn more about each of our upcoming events with workshops from DeepMind and talks from Shadow Robot and whatnot, please do sign up for our mailing list. This QR code should take you to a form that will sign you up for our mailing list. So if anybody has any questions now, you're welcome to raise your hand in the participants.
I will just add that with the various projects we mentioned like requirements of what you should know already. But like as Jay mentioned with her, if you are passionate enough, you will always be able to learn everything as you go. So if you think a project is really interesting and want to dedicate a lot of time, but aren't sure whether it's too difficult for you, we will be there to help you out, and I believe you will be able to join the project fully and contribute and learn a lot.
Yeah, definitely. With enough enthusiasm, any of these projects are definitely definitely not too advanced for anyone to join. So if any of you have any questions, you're welcome to shoot them in the chat or just raise your hand in the participants and we'll try and answer them. Otherwise, thank you all for coming. So if anybody has any questions, you're welcome to put them in the chat. Okay, yeah.
We can stay for another like 5-10 minutes to see if anyone has, we already have some questions right here. So
Marnier? Okay, yeah, I've unmuted you so far. So if you'd like to,
Hello?
Yep.
Hi, thank you. So quick question. Are we allowed to join more than one of these teams or is it limited to just one?
If you feel like you have enough time and you can manage the workload well enough, you're more than welcome to join more than one of these teams. In fact, you can join all of them if you'd like. Otherwise,
yeah, I'm assuming. Okay, the workload's too high.
Like
up to you.
Most of the committee members have are active in more than one project, so you certainly can do.
Yeah, definitely.
Okay, thank you.
That's just up to your discretion. Yeah.
We welcome you, to take part in all.
Thank you.
Thanks so much for your question. Yeah, thanks so much for your question. Okay.
Let's go through the chat.
Yep. So let's go through the chat. So do we have to apply for the projects through the form? So for the previous, that's actually a great question. So for the projects like the research project and RescueBot, where generally we advise from previous robotics experience, you're not required to send a CV, but generally it is quite helpful to see what kind of experience you have had in the robotics world or just in like the software development world. But otherwise, the form is just there for signing up for our mailing list, and most of our information about the society will go through the mailing list. So I still recommend that that you go through the form.
Just to add that, specifically for Rescue, will be if people are keen to join the project or work in a particular part of it. So we're having the newcomers meeting as on the date stated here, 14th of October, 5 p.m. And then we can, myself and other core members of the project can talk to you in breakout rooms or just on chat, and then we can kind of see where you can fit in the project.
Yeah, definitely. Yeah, thanks so much for that question. So will there be any in-person meetings this term or entirely online? So at the moment, we plan on holding some small in-person meetings because given the physical nature of a lot of the robotics projects, it's quite difficult to have entirely online. However, that's also subject to the state of the pandemic. If things get really bad again and we're just all locked down, then obviously everything will go online and we'll have to take a more software-centric perspective. So given the uncertainty of this term, that's kind of subject to change.
For the Varsity Minibots, you saw the hardware component, and there will be a competition where each team will bring the robot to the field to kind of do the run, and then they will do it sequentially. So there will be some in-person stuff going on for some of the projects, I guess.
Yeah. So if we filled out the Google form before, do we already have to do it again? No, you do not have to. Unless you'd like to and you'd like to submit like an updated CV or whatnot, you don't have to. We'll deal with that as it comes though, but you're not required to. In Varsity Minibots, do we start from scratch? No, there's actually a starter robot. So that robot that you saw in the video is actually the starter robot, and everybody gets that.
It's this one.
Yeah, so Kai actually has it already. So it's a starter robot that everybody gets, but obviously given the state of the competition and how competitive it is, generally a lot of people also make improvements to the robot itself. So that can be in the form of any part of the robot, but no, you don't have to start from scratch.
Ethan?
Yes?
Yeah, just to add, you are given parts rather than the robot itself.
Yes.
So you do have to assemble them. Yeah, just
Yeah.
add to.
Yeah. But the parts are already there for you. When are the meetings for the mini-bots, and do you have to attend them all? So Jerry, if you want to answer that. Yeah. Jerry, so did you see that meeting? Yeah.
So is it the session for Minibot?
Yeah. When are the meetings for the mini-bots? Are they every Wednesday? And do you have to attend them all?
Wednesday, 2 p.m. Hopefully you can attend all of them, because like it will include instructions, and we'll also try to keep you keep you up to date and to track your progress, so you won't be left behind. So I'd say, yeah, please do attend if there's nothing really like emergency or something. So yeah.
If something does pop up, obviously there's a bit of leniency there, but please do try and attend them all. Will it be possible to join a project in Lent term? So for most of our projects, yes. The RescueBot, InMoov, it's possible to join our projects in Lent term, but generally some projects it's a lot more difficult to join Lent term, our research projects especially, since at that point we'll be neck deep into our research, and that'll be a little bit more difficult to join in Lent. Would Varsity Minibots be a good project to do if you've already done the CUR mini project? Yes, this year we're kind of stepping that up. We're kind of stepping up. So if you've done the CUR mini project, that last year was Minibots, if I believe. This year it'll be a little more difficult, both from the hardware and software perspective. So it'll be a maze following robot, which is a little bit more difficult. And you also have Lent term to work on it as well, to improve the mechanics of it, to improve the software of it, and ultimately make it a lot more sophisticated, but albeit with a more difficult maze to follow. So how much experience is needed for InMoov? So generally, we look for some technical experience, but InMoov, again, is a learning project. So Jay, that's up.
As long as you are very interested in taking part in building this humanoid robot, I don't really mind if you don't have any experience. You just need to be very dedicated to the project.
Yeah. Yep, definitely. I think the main thing for all of our projects is that enthusiasm is a lot more important than past experience, because if you have a lot of enthusiasm, you can kind of pick up the skills afterward. Expected time commitment in terms of hours for these projects. So again, once again, that varies a lot. But generally across the board, we have weekly meetings, and we generally expect like a few hours per week. But I think that varies. So I highly recommend to attend the initial meetings of each of the projects that you're interested in, just to get a better gauge of how much time you need to put in, how much effort you need, and generally whether or not you're interested in the project. So I highly recommend just going to the
just to add on to that point about time commitment. Once again, like every project will have roles that require not a lot of time, but you do a little part of the whole project. But if you want to be in charge of a project, or make some new project or something like this, then obviously you're going to have to spend a lot of time, and that's like it's kind of unavoidable in that way. But the time commitment doesn't necessarily mean it's a bad thing. Like it's like working on this project, especially if you're like in an integrated part of a project, then it's super fun. You learn so many things, and also you're like in control of what you're doing. So like, although it might be a lot of work, it can be a lot of fun. So yes, you require time commitment if you want to be integral to the project. No, it won't require time commitment if you want to do some side stuff, but do consider about like how much you want to learn and experience you want to gain, because more time you spend, more experience you gain.
Yeah, definitely. Yeah. So same again, that kind of goes along with the enthusiasm point. The more time you spend, then the more skills you'll gain and whatnot. Will the projects be competitive to join? Some of them are a little bit more difficult. RescueBot, given the small nature of the team, is a little bit more competitive. But like, again, I highly recommend just going to the initial meeting, gauging whether or not you're interested, because I think we can always find a place for someone who's incredibly enthusiastic about the project.
Maybe it's worth mentioning that for this year, for the Varsity Minibots, like last year for the similar project, we approved anyone to come inside, regardless of how many numbers overall. But this year we're limiting it to, I think it was 24 people or something like this. We'll be more specific on this on the first meeting, but the point of this is that we cannot have large gatherings and large groups, and to increase our effectiveness of the project, we decided to put a cap on the number of people. So there will be some competitive nature on that project as well.
Yeah, definitely. And for the research project, does it have to be software development? No. To answer your question, no. It's just to make sure that you are able to program in some sort of commonly used language like Java, C++, or Python. But does it have to be enterprise coding experience? No. I mean, we're not running a corporation here. Is there enough opportunities for first years to do a related year up, or is it too competitive? To do a related year up. So for me, it would probably be the one to talk about this, but he's actually probably gone, if I'm not wrong. So
Is he still here?
I think he's gone.
Oh no, he's still here.
Oh, okay. Fubia, if you'd like to speak a little bit about that.
Sorry, I missed the question. What was it?
Yeah, so somebody asked, is there enough opportunities for first years to do a related year up? So I assume a robotics related year up, or is it too competitive?
Oh, I don't remember what was the requirement, but I don't think the first year cannot be Europe. I think it has to be second year or third year, if I remember correctly. Do you remember, Kai?
I did it in my second year.
I have quite a few friends that did Europe in their first year. For example, with the materials group.
Okay, yeah.
Definitely possible.
Yeah. If it's eligible, I will certainly consider. But if not, I cannot.
Yeah,
right.
Thanks so much. That's that. So if we want to join the Rescue Robot project, would be preferred if we send it a CV before the newcomers meeting. Yes, it'd be preferred, but if you don't, then we'll still be able to ask you for your past experience and whatnot. So, but it is preferred, yes. And lastly, are the initial meetings going to be in person? No, right now we're going to hold them over Zoom because it is not going to be great if we have super large gatherings in person.
Yeah.
Okay, so I think that's all the questions that everyone has written down so far.
Is there anyone like raising their hand or?
Oh yeah, that's a good point.
It seems fine at the moment.
Yeah, okay, so if that's everybody's questions, thanks so much for everyone coming. I realize that the format of this is a little unorthodox, but we really had a great time having an introductory talk, and we look forward to seeing you at our initial meeting. So please do try and sign up for our mailing list. We'll be sending most of our information through there, especially about our projects and the initial meetings and whatnot. So please do sign up for the mailing list. Thanks so much, everybody.
Hi, I have one last question.
Yeah, go ahead.
These initial meetings, are these going to be in person?
No.
No.
So this will be online.
Yes, it will be all online.
Okay, that's good because the thing is, I broke my ankle and I can't go to anywhere. So yeah, that will be for me.
No worries. In the middle of the pandemic, I don't think we're gonna ask anybody to go in person.
Cool. Thank you.
All right. Yep. No problem. All right. Thanks so much, everybody, for coming. Have a great day.
All right. See you.
Thank you.
Bye.
Thank you, guys. Bye-bye.
Thank you.
Thank you. Bye.
Bye. What the?